Hi all. So today we will be covering the basics of unit testing of Angular using the Karma Jasmine framework. So this is the default framework which comes along with any newly created Angular project using the Angular CLI. So Karma is basically a test runner which is used for running the unit tests which are written in Jasmine. So for today's video, we will be creating the unit test for this particular web application. So it has a login page. Once we enter the username and password, we will be redirected to our home page. So these are the two components, and this is navigated using the Angular routing. So now let's go to our application. Let's stop the application, and I am also stopping the server. So ideally, when we are creating the unit test, we no longer need the server application. So we will be replacing them with mocks. So let's get started. So if we go into our application, the major configuration file that is used by Karma is the karma.conf.js. So here, by default, some settings will be already created by the Angular CLI. So here you can see some various plugins which are used for connecting the Karma and Jasmine along with some reporters which can be used for generating the report of our test running along with if we need to have the coverage of our code, we can generate that as well. So by default, the reporter of our test result will be the Jasmine HTML reporter, and the coverage reporter here we have given. Here inside the coverage reporter, we can give the folder in which we need to create our coverage results along with the format, the HTML and the text summary. And we can define the port in which the Karma, like the web page, needs to start up along with the browser in which we are planning to run our unit tests. And another important property is the auto watch. So when it is set as true, automatically when we make any changes in our unit test, it will be rerun. And we need to make the single run as false, otherwise it will be exiting the Karma test runner after a single run of our unit test. So one thing to note is that if we go to our Angular JSON, we have a test section or a text target which is used for running the ng test. So here by default the coverage won't be enabled. So in case we need to enable the coverage for our unit test, we need to add the code coverage. So here you can see that by default the value is false. So we need to enable this. So unless we enable this, the coverage folder and along with the coverage reports won't be generated. So as of now, there are no existing spec files for this particular application. So the starting point of our testing is the test.ts file, which is automatically created by the Angular CLI. So here they have automatically added some zone.js testing, all those things which will be required for asynchronous testing. Here you can see that they are actually searching for the spec.ts files. So there are two ways in which we can create the spec.ts file. Either we can create it along with the actual code, like we have the app module or the app component.ts. We can create the app component.spec.ts here itself, or we can create a separate test folder and create it there. So ideally, we should be creating the test file or the spec file within the same folder as the code, so that it will be easier to track and we will be knowing which all components or services are having the spec files. So the first command we need to run is the npm test. It will be internally calling the ng test. Currently there are no spec files, so it will not be running anything. Now let's go to our login page, and here we have a login service. So first let us see how we can create a spec file for this service. So I am going to create a file called login service spec.ts. So I will remove all this. So the first starting point of a spec file is the describe keyword. So it basically points to a test suite. So test suite is a collection of unit test cases which we can create. So we need to first give a description for this test suite. So here you can see that our test runner is getting started, the Chrome is getting started. So since there are no spec files, it won't be running anything. So here inside our describe, first we need to give a name. So I am giving the name as login service, and we need to pass a callback. Within this test suite, we can define our test cases or the IT. So before we start with the IT, there are some special life cycles which we can call like before each. So before each is basically executed before each and every test case. So if we need to handle something before each test case, we can put that code inside the before each. Similarly, we have an after each in which we can do some cleaning up after each test case. Similarly, we have another callback called the beforeAll. So if we use this, this will be executed only a single time before the execution of all the test cases. Like suppose there are 10 test cases, it will be executed before the execution of the first test case. That's all. And similarly, after all is there. After all will be executed only a single time after the last test case. Usually we will be preferring the before each. So I'll be adding an empty before each as of now. And we can create the unit test. So the first unit test we are creating is whether the service is created. So here we can pass a callback. So we can see that in our login service, there is actually a dependency we are injecting, that is the HTTP client. So ideally, you know that the HTTP client will be making HTTP request to our server. So we won't be needing that within our unit test. So we need to mock this. So there are multiple ways in which we can mock our services. So for especially for the HTTP client, we have something called a HTTP testing module. So first thing we need to do is we need to create an instance of our service. So let's start with the login service. So there is something called a test bed. So a test bed is basically the consists of many utilities which can be used during the creation of the unit test. So we can start with testbed dot. There is a method called configure testing module. So this is similar to our ng module. So whatever configurations we can use in the ng module, we can use the same within our configure testing module as well. So here we can give the providers array and the provider which we need, that's the actual service, that is the login service. So we cannot mock the login service because we are actually testing the login service. So we need to declare that in the providers, but we can mock all its dependencies. So here in this particular scenario, what we are doing is we are making use of the HTTP client testing module. So this is available within the Angular common HTTP testing. So within that, we have the client testing module. So once we import this testing module, basically all our HTTP requests will be routed to this testing module instead of the actual server. So we need one more thing. So here we have configured the testing module. Now we need to get the actual services. So let's create a variable called login service, which will be of type login service. Similarly, one HTTP that will be of type HTTP client. And another thing we need is the HTTP testing controller. So this is basically something like a server. So we need to create an instance of this HTTP controller. So now we need to get the instance of each of these services. So first we will get the login service. We can make use of testbed.inject to get the actual instance. So similarly, the HTTP client and the HTTP testing controller we can assign to HTTP and HTTP controller. So once we have successfully created or mocked all the services, now we can write the actual test case. So first we are checking whether the service actually got created. So the login service, we are checking whether it is defined. So now if we go to our Karma application, you can see that our first spec is a success. And this here you can see the coverage summary, and this will be our reporter, the HTML reporter which we saw here, it will be showing here. And also within our application, a coverage folder will be created since we turned on the coverage, and within that there will be an index.html file where you can see all the coverage of our code. So basically you can see that the login service, you have the statements, the branches, functions, everything. So once you open that particular file, you can see the things which are marked in red are not covered and the remaining things are covered. You can get this information from the coverage report. So now let's actually call the login method. So we will create a separate test case. So here we will be actually calling the login API. So now let's paste the code which we are going to write in our unit test. So here basically initially I have created a constant test data which will be returning the actual output of our API. So in case a particular user ID password is successfully logged in, it will return a true. So that thing I have created as the test data, and it also needs an input, that's the username and password. So that is the input data. So after that, I am calling the login service dot login. So that is our service method, and within that I am passing the input data. So since I am actually returning a promise, I can use the then operator, and within that I am expecting that the actual data will be true since this is a valid username password. So since we are actually not calling the HTTP or the server side, we will be mocking that. So what we are doing is actually the HTTP controller, we are adding a expect one, that is we are expecting a call to this particular URL, that is the login, and here we will be getting a test request back. So first we are checking the whether the request method is post. So here you can see that actually we are calling the http.post. So here in case I change the method to get, here you can see that actually the expected assertion is failing. So that is the first step we are asserting. Then after that, we are actually fleshing the request. That is actually we are passing the test data as a response to this particular API call. So this is the actual place we mock the data. So once this flush happens, immediately the then part, or in case we are using an observable, the subscribe part will be executed, and this particular assertion also will be evaluated. So after this, actually we need to verify that there are no pending calls. So for that, we can add one after each. So we are adding this code in the AfterEach because we need to verify that no pending requests are present after each unit test case. So that's why we are putting it here. So the command is http controller dot verify. So we need to ensure that it is called after each test case. So you can see that our login API test case is also success. Now let's write a test case for the failure case. So now this is the test case for our failure scenario. So here we are actually testing for a status code of 500, that is an internal server error. So here initially we are checking a message, and again we are passing the input data. So this is similar, the login service dot login method we are calling with the input data. But here you can see that within our then we are actually passing two callbacks. This is the success callback, that is the actual then, and this is our error. So inside the error, what we are doing is we are checking the status, and we are expecting it as equal to 500, and the error message we are expecting to be equal to status 500 error. So now the remaining things are almost similar. We have an expect one, and we are expecting the login, and again we are checking the request method, it should be post. Now the difference will be, in case we have an error, here in the normal scenario we will be sending only the test data, but in case of error scenario we need to pass this second argument, and inside this we have the status, which will be a status code. So ideally in case of success it will be 200, we are passing a 500, and the error which we need to send back, that status text also we are putting it in the message. So now once we run our code, you can see that it is working as expected. So what happens is this status will be set as the error, HTTP error response dot status, and the status, the e message will be set as the error message. So here you can see that actually the same thing we could have done by making use of this catch. So here we needn't put this the fail statement. So here also you can see that even now our test case is working fine. But the problem is that in case I am sending the same thing as a proper data like success message, even then our test case will not fail. So that is why we are making use of the fail. So let's see the syntax for that. So here you can see that in case I had passed the success, that is the actual data, it will come and execute this particular portion. Here what we are doing is we are forcefully failing this test case. That is, we don't expect this test case to have a success scenario. So we are saying that it should fail and it should show this particular message. So if we go to our test case, it will, you can see that it has actually failed with the particular message which we gave here in the fail. So this is a global function that is available in Jasmine, which can be used to force fail our test case. So now if we undo our change, the error portion will be executed and the unit test will be successful. So this is one way in which we can mock the HTTP client calls. So now let's go ahead and create the unit test for our second service, that is a home service. So this also makes use of the HTTP client, and actually it returns a list of cities. So we will be mocking the HTTP client in a different way in this particular unit test. So I will copy our existing login spec and I will just remove all this. So I will be removing all the dependencies. So that's so that we can start from the scratch. So we will be needing our testbed.configure testing module, but instead of the login service, we will have the home service, and we need a variable called home service, which is of type home service, and we can use that variable here. And we don't need this HTTP controller, and here you can set the home service. So we are checking, the first thing will be, first test case we are checking is that whether our home service has been actually created. So we know that it won't be created because actually we have a dependency on the HTTP client. So Jasmine provides an inbuilt function which can be used for creating spies. So a spy is basically an object which can be considered as a mock, but it has some other functionalities, like we can keep track of it, like we can check whether it has been actually called. We can actually modify the data which can be returned from that. So there are multiple uses of a spy. So let's see how we can create a spy. So here I am creating an object or variable HTTP spy. So let's create that spy here. So the syntax is Jasmine dot create spy object. So here you can give the spy object name. So that is HTTP client. So that's a service name which we need. And within that, which all methods we need. So here we need to mock the get. So I am passing the get. So here the type I will be giving as get jasmine.spy. So that will be the type of our HTTP spy. And now this thing we can register it in our providers. So here I am making use of provide, and I am saying that HTTP client is the service name, and I want to use the value HTTP spy. So now let's see whether our unit test works. So here you can see that our home service is success. This is because we have replaced our actual HTTP client with our spy object. Similarly, if we check our branch, you can see that the home service is also listed here. And now we need to cover the different branches. So now let's add the unit test case for the actual get cities method. So I have added that here. So here that is it called get cities, and we will go through each of this syntax. So first let me import all the missing things. So one thing peculiar here is that I have added a fake async. So I will come to that. So first I have created a test data. So this will be the mock data that will be returned by our HTTP spy. So here what I am doing is the HTTP spy which we have created. Within that I am calling the get method. So that is the mock object, like the spy which we created. And the spy has a capability called and. We can append that, and actually if you check, there are multiple utility methods like call, fake, call through, lot of things are there. So here I am making use of something called a return value. So return value, basically what we can do is we can return a particular value from this By. So what I am going to do is, here if you see, actually the whatever is returned is an observable, and that particular observable we will be converting to a promise. So ideally we need to return an observable itself. So for that I am making use of rsjs defer. So within that I am passing a callback which will return the test data as a promise. So what happens here is we will be receiving a observable, and that we will be converting into a promise, and that particular data we will be equating within our test case. So here the home service dot get set is we are calling it. So within that we will be adding the then operator, and inside the then operator we will be checking whether the data which is coming from the API, that is a mock API, it is equal to the test data which we passed to this particular spy. Some additional syntax is needed to make this work. So in case I didn't give this fakeAsync, so ideally we won't be having these things. That's the fakeAsync and the tick. You can see that actually the spec has been skipped. Like it is saying that there is no expect method within or assertion within our unit test. So what happens is that since actually we have an asynchronous call here, like the promise is an asynchronous thing. So what happens here is that unless we give some special keywords like fake async or wait for async, the actual execution will be completed. The unit test will be executed before the actual code is getting executed. So for that, what we need to do is we need to have something called a fake async. So fake async is a Jasmine operator. So this will be able to handle the micro task, like the asynchronous micro task. We will be able to handle this, and within this we need to call this method called tick. So this will ideally move that fixed amount of time. Suppose we have a set timeout with a timeout of 100. So here we can pass that particular time slot here, and it will actually mimic like it is moving the time forward. So in our case, since we are making use of a promise, we need not pass any time, but we just need to simply call this tick. So immediately what happens is that this promise will be resolved, and this particular expect will be immediately executed. So now if we go back to our unit test, you can see that the get cities has been successfully completed. So this is one way in which we can handle asynchronous operations. So now let's go ahead and create the spec files for our components. So this is our login component. So you can see that it has two dependencies, that is a login service and the router, and it has a method called login, wherein which first we will be checking whether the username password is empty. Either of them is empty, then it will be showing a message, and after that it will be trying to log in, and based on the result, that if the login success, it will navigate to a home page, and in case it is an error, it will show the invalid login. Similarly, in case of any server errors, it will be showing the login failed. So now we need to write test case for each of the scenarios. So while writing test case for components, there are two parts. That is, one is the class part of the component. So what we saw now is the class part. Similarly, we have the HTML part. So we need to validate the HTML portion of the component as well. So here I have added a login component spec here. So I will go through each of the lines of code which I have added. As you can see here, there are two dependencies, that's the login service and the router. So we need to mock these services. So what I am doing is, like, I am creating a spy object. So within the login service, you can see that we are making use of the login method alone. So we need to create a spy using Jasmine code creates spy object, the service name, and within that the method which we need to spy. Similarly, I have created another router spy, and here I am using the navigate by URL. So I will give thus that particular method as a spy, and the object will be the router. So here I have created the login spy that is of type login, that is a Jasmine spy, and the router spy which will have a method called navigate by URL, that is again a spy. So now coming to the configure testing module. So this is similar to whatever we saw already in our service spec file. So one thing to note is that here actually we are testing our login component. So we need to define that in the declarations. This is similar to the ng module declarations. Why we are giving this imports is, here you can see that actually we are using the ng model within our HTML. So we need to add our forms module. Otherwise, what will happen is, like, I am removing the forms module, an error will be thrown that ng model is not a non-property of input. So that's why we need to add the forms module. So once we add that, all the errors will be cleared. And similarly, the spice which we have created, that the login service and router, we need to declare that in our providers. So the provide login service, I am giving the use value as the login service spy, and router, I am giving the router spy. So after this, we have some steps which are unique to the components. So this is one such step, that is a testbed.create component. So here is the step which actually creates an instance of the login component, and it will return something called a fixture. So the type of that is component fixture and the particular component which we passed. So this will be something like a test harness which will have multiple utilities which we can make use. So if we go to this fixture, you just type dot, you can see there are multiple things like component instance. That's the actual instance of our component. We have something called a debug element that will have the root element of that particular component. And we have also the native element, that's the actual DOM element. Once we get access of the fixture, we can access the component instance and assign it to the login component. So we saw that the component instance will hold the reference to our component. Similarly, I have created a debug element constant. So I am setting the fixture dot debug element to our debug, and again I am getting the instance of a login service and our router using testbed.inject. And here I am making something called a page. So this is a page class I have created here. So this is ideally class which I have created in order to simplify our unit test. So here you can see that we have multiple test cases which have or share the same type of code. So first we check whether, like, the username is empty. In case the username is empty, what is the type of error that is shown? Then we have something like the password. So again, the type of unit test which you are writing is somewhat repeated. So in such cases, we can make use of a class. And here I have given a test page. You can give it any name. So once we create such a page object, you can do something like, so here we have an input called username, right? So what we can do is, within our fixture.debug element, we have something called the native element. So this, there is a shorthand notation as well. You can ideally remove this thing. Directly we will be able to get the fixture.native element. So both these are similar. So using that native element, we will be able to use the query selector and get our particular user input. So that particular thing I have defined it as a getter. So similarly, we can minimize the code, like the repetitive code, we can wrap it within our page. So that is what I have done here. So now the only input that the page needs is our fixture. So I have passed it in the constructor. So once we have created the page object, now we go to the fixture.detectChanges. So using the fixture, we are calling the detectChange method, and this is needed whenever we need to run the change detection. Why we are running this initially is that we need to execute our ng on in it. We need to call this fixture.detectChanges. So once we have done that, our login component will be defined. So that's our first test case. Second, what we are doing is like we have the username empty check that is here. In case the username is empty, it will be setting this particular error message and we need to validate that. So let's go here. So first what we are doing is we are checking the model part, that is the login component dot username, that is the public property which we set here. It should be equal to empty string. Next what we are doing is we are getting the submit button. So this is a utility I have written here. It's a getter. So what I am doing is I am using the fixture.native element and I am query selecting the button. And once I get hold of that particular element, I will be activating the click. So I am calling the click method. So at that time what happens is here if you go to the HTML, the login method is bound to this particular button on the click event. So automatically our login will be called and this particular error message should be set. So once we click on that, we will be running the detect changes. Why we are running the detect changes actually, like we will be evaluating our HTML part, that's the bound value. So here if you go, we are checking here actually whether our error message is getting displayed. So in case I needed only to check the class value, that is the model, then I needn't run the fixture.detect change. But since here I am actually checking both, like first I am checking the model, whether the model is populated. So that is success. After that, I am checking whether the model is matching with actual content in our HTML. So here again, the error message is something similar. So here what I am doing is the fixture.debug element. Inside that I am querying. So this is a utility function within which we can pass this by.css. So this is basically a utility by which we can use the CSS query selector and like whatever the CSS selector accepts, we can pass it as the input. Like so here I am querying it using the class, that is the error. So here this particular error message p tag. So there I have given the class as error. So it will be querying that particular element. Peculiarity of this particular by.css is that it can be run on any platform. Like in case we directly make use of the native element, the debug element dot native element, what happens is in case it is not run on the browser, the native element may be null and our actual execution will fail. But the by.css is written in such a way that it has fallback mechanisms in case the native element is not present. So in case you are sure that your application runs only in the browser, then we need not make use of the by.css. We can directly query using our native element query selector. But in case you are running it across multiple platforms, like you are using server-side rendering or anything like that, then it will be a good idea to use the by.css. This particular query will return a debug element, and within that I am getting the native element. So coming back to our spec, so here I am getting that error message and I am checking the text content. So the text content should be equal to the error message since we are actually binding it to the HTML. So that is our first check. So similarly, we need to check for the password. So in case the password is empty as well, we need to have the same result. So one thing to note is that here I have actually filled the username. Why I have done this is that, like, suppose I didn't give this, what will happen is the test case will run, but when we go to our coverage part, so now if you see the coverage part, you can see that the branch coverage is not covering this particular check. That is because this check will be executed only in case our username is not empty. So in case I did not give any username here, this password code will never be executed. So this is something called the branch coverage. So for achieving that, what we need to do is we need to populate some value within our username. So now when I uncomment that particular piece of code, you can see that this branch is also covered. So what we are doing here is, like, again, I am making use of a utility here. So ideally, I am query selecting our username field. So that is using the page.username input. So this is again a getter which gets the username. And once I get that, what I am doing is I am setting the value as admin, and I am so instead of admin, I should give the value here. So I am setting the value, and once I set the value, we need to send a dispatch event from this input with the event as input. So unless we do this, the actual chain detection won't be triggered. So once we do that, then we will be able to check whether the username has been modified, like the model has been updated to admin and the password is still empty. Then we click the submit button, and again we repeated the same steps. So again the error will be created. So now let's go to our next unit test. So here what I am doing is we are providing the valid credentials. Again, I am making use of the utility, like I am passing admin in the username and the password field. And here again, one thing is that we here have a asynchronous operation. So again, we need to make use of the fakeAsync or waitForAsync. So previously I had told about the waitForAsync, but I had not shown it. So this is how we need to write it. So we have the waitForAsync. We need to wrap it with our callback. And once we do that, we get something called a fixture.whenStable. So this is returning a promise, like whenever our fixture gets stable, that promise will be resolved. We are mocking the asynchronous call, like when we call the login spy, I am returning the value as a promise.resolve true. Once our fixture is stable, we will be calling the Detectchanges, and we will be querying our error. So here you can see that once it is success, this error message won't be there, and as a result, this particular p tag itself won't be there. So when I try to query that using the class, it will be returning a null. So I am checking whether that value is null, and it is. Based on the success part, one more thing we have, since I am returning the true value, I need to verify that the router is getting navigated to the home page. So here again, I am using the router.navigate by URL spy, and here I am checking whether the first call to this navigate by URL is having the argument, like I am selecting the argument of the first call, and I am checking whether that argument is home. So ideally only a single call will be made to this navigate by URL in our test case. So since we are using the home, that particular test case also will be success. Now the next test case is for our invalid credentials. So here I am giving a invalid password, and I am mocking the response as a false. So in case it is a false, the error message will be set as invalid login. So I am basically querying the same thing here. So here, instead of the waitForAsync, I am making use of the fakeAsync. So using the fakeAsync, again, I am calling tick to run the asynchronous thing synchronously. And after that, I am calling this Detectchanges so that our error message will be updated here. And I'm checking whether the invalid login is displayed as the error message. So the next thing is, in case we have an API error. So here what happens is, in order to mock an API error, what I am calling is, I am calling something called reject with. So inside this, I am making use of the throw error operator in RSJS, and I am giving the message login failed. So login failed is a message that actually we need to display here. So I am throwing that here, and when I click the button, that particular error message will be thrown by the login. So after that, I'll be calling the tick so that the asynchronous operation is completed. And here again, the login failed message, we will be checking whether it is available in the HTML as well as in the model. So this is how we have written the unit test for our login component. So now let's write the unit test for our home component. So the home component HTML is like this. It basically consists of a unordered list, and it will be showing the list of cities. And here we have p tag, inside which we will be showing the city name, which is capitalized. And also we are using a directive here called highlight. I am highlighting the background as yellow. Similarly, I have the image, which will be having the src as the city.image and alternate text as city.alt. So coming to the home component, you can see that here I am making use of the home service in order to get the list of cities. But one peculiar thing I did is that instead of making use of the root injector, I am making use of these providers within the component so that I will get a particular instance of that home service within my component. So in case I use this component in multiple places, I'll be having multiple instances of this service. So now let's see how we can cover this in our unit test case. So here I have created a spec file. So as you saw earlier, we have the providers. Only one dependency is there, that is the home service. So normally what we'll be doing is we'll be creating a mock. Like, so here I have written a stub, home service stub class, and within that I am using the method get cities, and within that I am returning a sample test data. So now what happens is, normally we would have used the providers array within our configure testing module, and here we would have made use of this particular thing. So here let's see what happens in case we make use of that. So I am making use of the normal home service. Now when I try to run, you can see that actually the mock is not taking effect, and it is still calling the actual service, the home service, which includes the HTTP client and all those dependencies. So in order to mock this, what we need to do is that we need something like, we need something called override component. So this will be available after the configure testing module, and using this we will be able to override some metadata of that particular component. So here the first parameter is the home component, and within that I am passing the partial metadata that needs to be overridden. So using the set keyword, we can pass the partial metadata. So here what we need is that the providers which are declared within the providers array of the component. So that part we need to override. So instead of the actual home service, we need to make use of the home service tab which we have created, and using that we will be able to run our test cases. So that is one main difference within the home component. Other than that, everything is similar. We create the component, we create the fixture, and inside the fixture we have a component instance, and we run the detect changes to trigger the ng on it. So our initial test case is that our code is mainly in the ng on init and it is asynchronous. We need to ensure that the cities, that is the model, gets populated with the data. So here, since it is an asynchronous code, I am making use of the waitForAsync, and within that I am using fixture.whenStable, and inside the then part I am checking whether the home component is defined and the cities is equal to the test data which I have declared here. So that should be success. So here you can see that it is success. Now let's verify it in our HTML. So this is also similar. First we will be checking the when stable, and once the fixture is stable, we will be running the detect change so that our changes are reflected in the HTML. And using the CSS by.css utility, I am querying all the p tags, and I'll be looping through each of these debug elements and checking whether the content is equal to our test data.name. But one thing to note is that here actually we are making use of a capitalized pipe, so that we need to include in our declarations. So the capitalized pipe as well as the highlight directive which we make use in our HTML, that we need to add it in our declarations. And in order to make the data equal, I am calling the capitalized function which is present within Lodash. So using that, I am equating the text content. Similarly, I am querying all the image tags, and again I am checking whether it is equal to the model value is equal to our HTML bound value. So that is all within our home component. Now let's see how we can create unit tests for the pipes. So we already saw in our home component that we are making use of the capitalized pipe, and as part of the spec file for our home component, the capitalized pipe is also covered. But in case you need to create standalone unit test cases, this is how we can do that. So this is our capitalized pipe, and basically what it is doing is it is accepting a value, and it is just calling the capitalize from Lodash and returning that particular value. Now let's see how we can create the spec file. So within this, we can create an instance of our capitalized pipe. Since it does not have any dependencies, we can directly use the new operator, and I am creating the instance pipe. So within that, we can directly call our pipe.transform, that is the public method, and we can pass some mock data, like I am passing ABC and I am expecting it to be capital A B C. So that is our first one. Similarly, I am passing multi-word also. So this is how we can create spec files for pipes. Now let's see how we can create spec files for directives. So here we have a highlight directive. So this directive basically does nothing, like it accepts an input, that is the background color, applies the color as the background color of that particular element. So whatever element we are applying this directive, it will change the background color. And it also adds a custom property in order to identify that actually we have added that directive to that element. So in case we have not added, or we query an element which does not have the highlight directive, this custom property won't be there. So this is our directive. And now let's see how we can create test case for this particular directive. So you already saw that this directive was part of our home component, but only a minor functionality of that directive was being used in that component. So in order to test that entire functionality of a directive, what we can do is we can create a test component. So here you can see that I have created a test component, and within the template we can provide the different scenarios in which we can use the highlight directive. So here I am using it as a string. Here I am not passing any value. So the default value, the default color will be applied. The third one does not have the directive itself. So in this case, the custom property won't be there. And the last one is actually a dynamic, like we are passing it as an input, and this is taken from a actual variable. So that is the value of this particular input. So this is how we can create test components, and this test component we can add it in our declarations of our spec file. So here in the highlight directive test suite, I have added both the highlight directive as well as the test component. So using that, we are creating the component and detecting the changes, everything. Now we query all the directives. So this is one utility using which we will be able to query all the occurrences of a particular directive. So here we are passing the highlight directive, and since you can see that highlight directive is applied to different types of elements, like it can be h2, it can be input. So instead of querying it like individually, we can query it using the directive itself. So it will return all the debug elements for this particular matching this particular directive. Similarly, we are querying the element in which we have not applied the highlight directive. So using this CSS query, we are selecting that as well. So now we can, first we are checking whether the number of elements on which the highlight directive has been applied. So here you can see that only 3 of them has. So we are evaluating or asserting that only 3 are present. Similarly, we are checking for the hard-coded value, that is yellow. That's the first element. Second element, we are checking whether it is the default color. So here you can see that we are able to access the directive instance itself, and we will be able to get that particular property. So since this is a public property, we'll be able to access it. The third one is the dynamic part. So here again, what we are doing is we are setting the input value and dispatching the input event so that the particular updated value. So the value is green. It will be updated in the model, that is a BG color, and the ng on changes will be triggered. That's why we are running the detect changes. And once it is run, we will be checking whether that input background color has been changed to green. So the last one is that the element in which we have not applied the directive, we are ensuring that the custom property is undefined. So this is the way in which we can write spec or a unit test for a directive. So the final component which needs to be tested is our app component. So if you check the HTML of the app component, you can see that only a single router outlet is there. And based on our app routing module, the default route is the login, and the other route is the home. So that is linked to the home component. So this is the actual routing configuration of our application. So now let's see how we can mock this same thing within our unit test case. So let's go to the app component spec. So here what we can do is there's a module called router testing module, within which there is a method called with routes. This is similar to our normal router module dot for route. So whatever configuration we have given in the module, the routing module, we can provide the same thing here as well. Only thing is that whatever components we have linked it here to these routes, we need to mock them. Otherwise, what will happen is it will be calling the actual component with all the dependencies, and our test case will be a mess. So for that, what we can do is we can just create something like this, the test components. So here you can see that I have created the login component with just the template as login component, and similarly the home component as well. So I am using these steps instead of the actual component within our router module. And again, I have declared the same within our declarations. And now we create the component fixture and get the component. For running a particular test suite alone, what we can do is we can put the fdescribe, and once we add that, all the other test suites will be skipped and only that particular test suite will be executed. So here we can go step by step. So what we are doing is, initially we expect that the app component is defined. Since the app component does not have any dependencies, it will be defined. And after that, what we are doing is we are getting the router service, and we are assigning to a constant, and also the location service we are assigning to a constant. So after that, we call something called the initial navigation. So what it does is it will be going to the initial route. So initial route of our application is empty route, and what we are doing is we are, whenever the empty route is coming, we are redirecting to the login page, login route. So the login route is our login component. So let's see what will happen. So one thing to note is that actually we are calling the tick using the fakeAsync here. So why we need to do that is that this router events are asynchronous in nature. So in case we didn't use this, let's see what happens. You can see that actually even though the route has changed, so it has come to the login component, but still the route is pointing to the default route instead of the login route. So for that purpose, we need to make use of the fake async and tick. And once we add those, you can see that actual route is success and the login component is being displayed. Similarly, we can navigate to our remaining path, that is a home, using the router navigate and again calling tick. You can see that now the home component is getting displayed here. So this is how we can create unit tests for router outlets. Similar to the fdescribe, we have something else called the xdescribe. So once we add that, that particular test suite alone will not be executed. So here you can see that that alone got skipped. Similarly, we can do the same thing at the unit test level as well. If we put xit, it will be skipping that particular unit test. And if we put fit, that particular unit test alone will be executed. So one more thing to note in our karma.configuration is that here you can change our browsers. So here I am giving as Chrome headless. So in that case, what will happen is that instead of launching a Chrome browser, it will be executing the Chrome as a headless. That's a background process. So let's see. So now you can see that the Chrome browser was not started, but only the Chrome headless was run. And you can see the result here and the coverage as well. The coverage report will be generated as usual. Here you can see that everything is 100%. So now let's see how we can debug a unit test within our Karma test runner. Once the Chrome browser is launched by the test runner, we can go to the source, and like normally what we can do is the like suppose we want to debug our login spec. So all the spec files will be listed here. So I am going to the login component spec file, and suppose you need to debug this particular test case, put a debugger there and just refresh the page. So the execution will be reaching that particular statement, and from there we will be able to debug like a normal JavaScript. So this is how we can debug our unit test cases using the Chrome browser. Hope you are able to get a good understanding about how we can create unit tests using Karma and Jasmine for Angular. See you soon. Thank you.